All righty, so here comes our practice quiz. Now, this is actually 2 quizzes, so it's not going to be this long, but it will be several problems. So let's look through this and get this sorted out. I know, and I wish the quiz were today, but we'll celebrate your birthday bonus tomorrow. Happy birthday. This is a great day to have a birthday. All right, so here we go. Please pay attention. This should be an easy quiz. There should be no reason that you can't do really well on this. Pay attention. Maybe take a picture of this before you write on it, and then take it home and do it again tonight. All right, here we go. We want to know, what are the coordinates of the vector from A to B? I don't care how you figure that out, but somehow you have to come up with 5, 4. Now, again, I don't care how you figure that out. I'm going from 1 to 6. In my mind, that's simple. It's 5 steps. I'm going from -2 to 2. That's 4 steps. If you want to subtract and do 6 minus 1 and 2 minus -2, I don't care. It doesn't matter how you do it, but that is the only correct answer. Got it? All right. What does this even mean?
No idea.
Okay, no. Yes, it's like absolute value, but in vector land, this is the notation for magnitude. We can't keep talking about that, guys. You got to remember, in vector speak, absolute value means magnitude. How do we find magnitude? It's the square root of
The first one plus the second.
not first one squared plus the second one squared. So it would be 9 plus 1, or the square root of 10. I'll say it one more time. To find magnitude, we square, add them up, and take the square root. Every time. Anytime, it's magnitude. Now, we're going to add 2 vectors together. Remember how we do that? We add the x's and we add the y's. Now, we're adding vector v, which is -3, 1, plus 2 times vector u. Now, what is 2 times vector u? 2, 8, right? No question about that. And then we're going to add. So when we add like terms, x to x and y to y, our answer is -1, 9. Right? Okay. Now we have, I think you can go past. Okay, thanks. All right, now we have this. Now, what is the first thing we're going to have to figure out? BC. What is vector BC? So, BC is the vector from B to C. So, we're going from B to C. So, that would be -1. And B to C would be +2, wouldn't it? So going from B to C, so going from 6 to 5, that's back 1, and from 2 to 4, that's up 2. Now, we got a negative out in front of that, though, which means what? +1, -2. All right, and then we have 5. Now, what are we going to have to do first here? Figure out what's in there. So, let's do 2v. What's 2v? 2v would be -6, 2. 2v Now, what would 3u be? So 3u's would be 312. Everybody with me? So 2 times the v numbers, 3 times the u numbers. Now we're going to add them together. So what do we get when we add them together?
9.
No, -6 plus 3.
Oh.
-3. And 2 plus 12, 14. Am I done?
No.
No, because we have this, right? And what did we say that means all the time? Magnitude. And how do we find magnitude all the time? We square the first one, square the second one, add them together, and take the square root. So what is that? 205? Does 205 break down? Nope, actually it doesn't. It's 5 times 41. So the answer is just root 205. All right, let's back up. Lots of work on that problem. How do we take 2 times the vector? Just do it. 2 times each number. And 3 times each number. Add them up. It's adding like terms. It's add the x's, add the y's. Okay? And then find the magnitude. 6. We want to find a unit vector in the same direction as AC. Okay, so first of all, let's find, stop it! Let's find the vector from A to C. Okay? A to C. So we're going from 1 to 5 and from -2 to 4. So the vector from A to C is 4, 6. Is everybody getting 4, 6 one way or the other? Somehow you're coming up with 4, 6. Okay, now we need to make that a unit vector. It is not a unit vector. Unit vectors have a length of 1. What is the length of this vector? Magnitude. The length of this vector would be 16 plus,
36.
so the square root of 52, which does break down into 2 root 13. So the magnitude of this vector is 2 root 13. What do I do to make it a unit vector?
You take each of the twice and put it over 2.
Exactly. So I'm going to take both of these numbers and divide them by 2 root 13. So 4 over 2 root 13 and 6 over 2 root 13. How do I make a vector a unit vector? I divide each coordinate by the magnitude. Now I simplify. Personally, when I simplify, I like to take care of this part first. So 2 will go into 4 and leave me with a 2. So that's 2 over root 13. And 2 will go into 6 and leave me with a 3. That's 3 over root 13. Now I'm still not done. Everybody see what I did? Cancel those extra numbers. Now what do I have to do? I gotta move the root 13 to the top and make a plain 13 in the bottom. So it's gonna be 2 root 13 over 13 and 3 root 13 over 13. And that will be my final answer. Okay? So far, so good? All right. Now, number 7, and the reason there's a squiggly line to run across there is these last 2 problems require calculators. So you'll need to have a calculator tomorrow. Okay, so number 7, find the direction angle for this vector. Okay, so we're going to find the direction angle. So the first thing we do is draw a picture of it. So over 3 down 2 looks like this. Now it doesn't have to be a perfect picture. Don't get all hung up about that. You're going right 3 and down 2. And draw my butterfly bow tie. Awesome. And it looks like this, right? Now this question says, find the direction angle. This is the first step. I need to find that angle. That's the first step. Okay? So anybody remember how to do that? I can use tangent. I can say tangent theta equals negative 2 over 3. Is that right? And then to find theta, I do second tangent. Very good. So I go to my calculator. And second tangent, 2 divided by 3. So this angle is 33.69. Now, if you put the negative in, that's fine. It doesn't hurt anything. It doesn't make any difference. But that's not the answer. Do you remember? The answer is this angle. That's the direction angle. Okay? So how am I going to find the actual answer? Subtract from 360. So the actual direction angle is 360 minus 33.69, which is what? Help me out. 326.31. Is that right? Are we okay, guys? Remember, if you draw your vector, like we drew ours right here, if you draw it and it's not in quadrant 1, you have to do some kind of finagling with the angle. The calculator isn't going to give you the answer unless it's in quadrant 1. Okay, number 8. Find the components of vector V as drawn. So the vector looks like this. And we want to find the components. Who remembers what that vocabulary word means? Components. What am I looking for if I'm looking for components? Emma?
Is that the X and the
It is. Components are the X and the Y. I'm looking for the X and the Y. And in that picture, isn't this the X and this the Y? So how did we decide we were going to find those? We did a bunch of these the other day. Emma?
cosine and sine?
I'm going to use my SOHCAHTOA, trigonometry. So I'm going to look here and I'm going to say, okay, cosine 32. Remember, it's always cosine. Okay, Jalen Buford, right here, buddy. Sorry, I'm on. Jalen, right here. Cosine 32 equals x over 16. Cosine angle equals adjacent over hypotenuse. So 16 cosine 32 is going to be my x value. So 13.57. And then how will I find y? Same thing, only sine. Remember, x is always cosine and y is always sine. Always, always, always. .48. Now, this is a bit of a tricky problem.
Isn't x negative?
Yes! Thank you. Remember, if you aren't in quadrant 1, something's going to be negative, right? So in that quadrant, the x is negative, and you have to physically mark it negative. You're not in quadrant 1. Very good, Kennedy. Thank you. Okay? Anybody have a question about the front before we go to the back and do it again?
Again.
Yeah. Practice is good. Practice makes perfect.
Practice makes better.
Yep, we're going to get better. All right, so here we go. This is another practice quiz.
Right, Riley? Right, Riley?
All right, so would you answer question number 1 right now on your own? Question number 1 says, what are the coordinates of AB? Do it right now, hurry up. Quit singing.
Negative.
Just wait. Give everyone a chance. Okay, raise your hand if you think you have an answer. All right. Who wants, Judah, you want to share your answer?
Negative 4.2.
How many of you agree with Judah that it's negative 4.2? He is correct. We're going from 1 to negative 3, that's back 4. And we're going from 2 to 4, that's up 2. Perfect. That's what you got to get. Somehow you got to get that as AB. Anyone have a question about that? All right, let's look at number 2. The question is, are BC and V equal to each other?
No.
Well, now wait. Before we can answer that question, don't we have to figure out what BC is? So B to C. B to C would be 4, 1. And V is, negative 2, 3. Well, that's not even close, is it? So the question is, are they equal? The answer is no, because they don't have the same coordinates, right? They have to have the same coordinates. All right, try this one. Do V plus 2W on your own. Let's see if we can come up with a consensus on the answer. I got negative 211. Anybody else get that? A couple of you? We okay with that? Anybody have a question about number 3?
I got 5.
3 plus 8. No, is this a subtraction? No, it's an addition. So it's 3 plus 8. remember, if you're finding the coordinates of the vector, that's when you say, okay, I gotta go from here to here. When you are adding, you just add. Just add them. These are different problems. All right, what does number 4 mean? So the magnitude of vector V is going to be the square root of 4 plus 9, I got root 13. Remember, if it reduces, you need to reduce it. Root 13 does not reduce. All right, so V is negative 2, 3. I'm going to make that a unit vector. All right, Caroline, we just did one of these a little bit ago. Do you remember? How do we make it a unit vector?
Well, first we just square them and then add it.
So first I need to find the magnitude, because I'm going to divide both of these by the magnitude, right? That's how I find a unit vector. So I need to find the magnitude. I just did that. Isn't that root 13? So your vector is negative 2 over root 13 and 3 over root 13. There's the first step. Right? But I'm not done, am I, Zion? What do I need to do? You know this.
Wait, we're not done?
No. Why are we not done? Because we got a radical in the bottom.
We had a radical in the bottom of the last one. I promise you we did.
Well, I fixed it. Yeah, I fixed it. You may not have done it, but we did it. We fixed it. So, Zion, we multiply top and bottom by root 13, so it puts the root 13 in the top and makes the bottom a plane 13. So 3 root 13 over 13 is the y, and negative 2 root 13 over 13
You
is
have to
the
be
x.
trying to make me
Oh, we put it over the
I
original.
promise you we didn't do it.
We put it over the original.
Magnitude.
Okay. Because I put it over the original.
No.
Or I did.
Don't talk to me.
So to find a unit vector, you simply take the original coordinates and divide it by the magnitude. Okay? Remember that. All right, now we're going to find the components of this vector. So its magnitude is 10 and its angle is 42. What do we mean by components, Ike? X and Y. So I am looking for X and Y, and in my picture, this will be X and this will be Y. Ryland, remember how we find X and Y?
Yes.
Good.
We have to figure out if we're gonna use 10 or
Okay, so when I do X and Y, I use sine and cosine, okay? So, cosine angle, so cosine 42 equals adjacent over hypotenuse. So X will be 10 cosine 42. And then sine angle, so it's always cosine of the angle, sine of the angle. So sine 42 equals opposite over hypotenuse. So Y is 10 sine 42. Then I just type them in on my calculator. And the last time I did this, I had to worry about negatives. Am I worried about negatives this time? No, because thank goodness we are in quadrant 1. And when we're in quadrant 1, we don't have to worry about negatives. So this is the answer. This is what goes in the answer button right here. That's kind of your work. This is the answer. You're looking for the coordinates, the ordered pair that represents the vector's movement. Find the magnitude and direction. Okay, so the first thing I'm going to do is draw a picture of this vector. I'm going left 2 and down 5. So that's a picture of the vector. Right? Now, what is, this would be the magnitude right here. That's the magnitude. In an airplane problem, it's the speed. The length of the vector, the speed of the vector. So what would that be in this case? This will be the magnitude. The magnitude will be the square root of what? 4 plus 25, so the square root of 29. How do we find magnitude? Square the first one, square the second one, add them up and take the square root. Every time. Now I need the direction angle. Now I'm going to start with this. This is not going to be the answer, but I'm going to start with that. And this, Ryland, is where I'm going to use tangent, because I'm going to say the tangent is 5 over 2, because tangent is opposite over adjacent. Tangent is y over x. Y over x. Okay, so I'll go to my calculator, and what do I have to type in? Second tangent, 5 over 2. What happened to the negatives? They canceled. So I got 68.20. But if you put that down, you'll be wrong, because the actual angle is this, right? So how do we find our direction angle?
180 plus.
180 plus. Very good, Emma. 180 plus, which will give me 248.20 degrees. Is that good? And one more. Sketch the vector represent. Oh, this was a test question a long time ago. You got this. This is a test question now. It's a course of an airplane, so this is navigation. So this is the way we label a navigation land. Okay? So it's a course bearing of 220. So 220 will be right here, won't it? Is that right? That's 220. Traveling 190. Where do I put the 190? On the line. So this is 190 miles an hour. So we're just drawing that. Tomorrow we have a quiz. This was 2 quizzes, so it's only got half that. Okay? Everybody understand tomorrow? Gotta have a calculator to do some of these problems. Okay. Let's get out our note sheets then. And let's pick up where we left off. Which I think for you was, we're ready